very good day. My name is Gosalai Ramalingam and today I'll be presenting about my final year project which entitled of Effect of Core Density on Low Velocity Impact Response of Polymer Foam Core Sandwich Structure, and it is a case study. The problem statement in my case study is only the parameter of density of polymer type foam is considered. The second one, fracture toughness of phase sheet bond when subjected to impact loadings is only reviewed. And the low velocity impact test is only considered in this case study. The objective of this case study is to investigate the effect of core density on low velocity impact response on foam core based sandwich composites. Second, to make analysis based on comparison of existing foam filled sandwich structure. Well, what is sandwich structure composite? It is a structure which consists two thin layer which we call as skin or face sheet and lightweight core in between the structures. And this case study it describes about the behavior of a beam, plate or shell which consists of these three structures. The core is bonded to the skin with an adhesive or with metal components by bracing together, which we know as stitching method. Well, the face sheet and lightweight core in this case study, which is considered, is polymer foam core with different densities subjected under low velocity impact test. Well, this is the progress of my case study. First, I define the research questions. I question myself whether I can complete my final year project with the previous title, and I conclude that I can't to do all the parameter that I decide to do in the previous studies. I choose only the density of polymeric foam and I started my research from there. I select search strategy which I know only the parameter of density of skin of the core is only that I need to search. I define the study's inclusion and exclusion criteria. I set the study quality assessment criteria, and then I search the studies in Science Direct, which it helps me a lot. I remove all the unrelated studies while reviewing all the review paper, and I only consider the density of polymeric foam, and then I pre-screen my studies to my supervisor and I detailed the screening. I presented my work in table form to my supervisor, and then by adopting the backward snowball technique, I completed my studies. The backward snowball technique is the guideline of using snowballing as a way to search for relevant literature which was successfully done and applied to systematic literature review. And from here, is any study found via backward snowball technique? Yes. And then I apply the illusion and I repeat the review and I stop doing my report with a conclusion. This is the result for my case study. The table shows the mechanical property of foams, and the foams is belong to a PVC foams. In the table, we can see that C60, C80, C100, C130, C200, PET 105, PET 135, L90, L140 is the foam of PVC with the different densities. The mechanical properties and perforation energy is also listed. The graph below, it shows the graph indicates the density of three densities of foam which belongs to the lowest 80, C80, just like C60 and C100 foams, C130, C200, and the plotted PET 105, PET 135, while the next are about L90 and L140. And these lines concluded that for plain foams, higher density achieve a failure mode and a high tensile stress under indenters rises to low energy mode of fraction. Therefore, the lower density foams fail in the higher energy sharing mode, while the high value of density failed as a result of a lower energy combined tensile or shear system. Such researches indicates the perforation resistance of such foams and also increasing the density of the foam helps to increase the initial stiffness of the board, the average load, and the overall measured displacement. This table is about the perforation energies of foams, and the graph is drawn beside. Well, this graph suggested that the higher densities cross-linked foam would have outperformed their linear counterparts if failure had occurred in pure shear mode rather than a mixed shear or tensile mode. Well, at last, it is clear that PET foams give the lowest perforation energies. While this table is about perforation energies of foams and the graph is drawn beside. This graph suggested that the higher density cross-linked foam would have outperformed their linear counterparts if failure had occurred in pure shear mode rather than mixed shear or tensile mode. At last, it is clear that PET foams give the lowest perforation energies with values roughly one half of those provided by cross-linked foams. This statement is proven by D. Feng and F. Imerick in their research also by using carbon or epoxy face sheet with the PVC foam core, which they say that mechanical reaction of the foam depends heavily on its density, and they concluded that increase in the density of the foam lead to substantial change in the elastic module and stress. Well, this table is a study on experimental and numerical investigated the effect of layering of the foam core of sandwich structure with the aluminum face sheet AL1050 they used and polyethylene foam, and also arrangement of this layer on the ballistic resistance of a high velocity structure is carried out. And according to the table above and figures, it compares the ballistic limit velocity of SP1L, SP1M and SP1H sandwich structure together. We can see that increasing core density increases the ballistic velocity. Table shows the numerical and experimental value of ballistic limit impact velocity with the different value. In comparison of other sandwich structure of similar weight, the ballistic of SP1 and SP1L structure is much greater and lower, suggesting that the mass of the structure has a major impact on ballistic resistance. And they concluded as the denser the object, the more resistant the projectile will enter counter, and thus the more energy will be absorbed. This table is the analysis of impacted sandwich specimen with carbon NCF or epoxy facing and Rohacell PMI foam core, which showed that these panels exhibit the unique action of the injury. This table is the analysis of impacted sandwich specimen with carbon NCF or epoxy facing and a Rohacell type of a foam core, which is PMI, showed that this panel exhibit the unique action of the injury. On the other hand, the variation of the thickness, form, and the density of this core resulted in significant deviation from the reference sandwich structure with damage sites but will still display a similar overall behavior. This concluded that it is proven with the compressive test on foam specimen, which this means density of core is an important role in these findings too. The conclusion for this case study is that density of the foam core affects the structural response to the impact panels. And in conclusion, I would like to conclude that the energy dissipated during impact seems substantial independent to the core density, which means core density plays a main role in toughness of the face sheet and the damage occurred on the face of the sandwich structure. The recommendation that I would like to do for this case study is To apply the stitching method to the core and face sheet. As we all know that stitching method is a very effective way to make sure the sandwich structure is in its correct position during the impact test under the low velocity impact is applied. Well, it is to measure the time taken for the fracture of the panels to occur to certain cost density. The second recommendation is to do more experimental analysis for some condition of form and size of panel used to examine the sandwich panel. Thank you.